When we went over Hess's law before, the goal was to combine several reaction steps into one overall reaction and to calculate the change in enthalpy or heat for that overall reaction. The rules for manipulating reaction steps were: if you reverse the reaction, you had to change the sign of delta H. If you multiplied the reaction by some number, you multiplied delta H by that number. If you divided the reaction by some number, you divided delta H by that number. And when you combine the reaction steps, you add their delta H's together. Now we're going to follow the same steps to calculate the equilibrium constant K for some overall reaction, but there's slightly different rules that apply. When you reverse a reaction, change K to 1 over K. When you multiply a reaction by some number, raise K to that number. When you divide the reaction by some number, raise K to 1 over that number. And when you combine the reaction steps, multiply their K's together to get a total. In the example, we're given the reaction 2A plus B yields 2C. The equilibrium expression is the products over the reactants raised to their respective coefficients. The reverse reaction would change the equilibrium expression to reactants over products, and K would be 1 over K. If the coefficients were multiplied by 3, each reactant and product would be raised to a coefficient that's multiplied by 3, so K would be raised to the power of 3. The second reaction is 2D yields E, and its equilibrium expression is the product over the reactant, raised to their respective coefficients. When you combine the two reactions, you get an overall reaction of 2A, B, and 2D yields 2C and E. The equilibrium expression puts the products over the reactants, each raised to their respective coefficients, so the K's are multiplied together.